This video is an example for a right tail test for population proportion. In this example, it's claimed that the proportion of college students who use campus cinema is claimed to be greater than 43.4%. A survey conducted among 44 students showed that 21 out of those 44 students indicated that they use campus cinema. A verified claim using alpha equals 0.1, and we're going to start with what parameter we are testing for, which is P. P is the proportion of college students who use campus cinema, and the claim made about P is that P is greater than 0.434. So, using which we can obtain the definition where the null and the alternative can be decided upon. So, the alternative is the claim here because it does not have an equal to sign, and this statement that doesn't have an equal to sign must be in the alternative, and with the equal to sign, if it had an equal to sign, would be in the null. So since this claim doesn't have an equal to sign, it actually comes in the alternative. So the null is the complement of the alternative, the exact opposite of what you see here. So the exact opposite of P greater than 0.434 is P less than or equal to 0.434. Step 1 is now complete. Step 2. Alpha is 0.1. So since alpha is 0.1, that would imply 90% confidence in our conclusion. Step 3. We find the test statistic. The test statistic is P hat minus P naught over square root of P naught times 1 minus P naught over n. Keep in mind that I'm using one of two possible test statistics. This is called the score statistic. I'm using the score statistic in this problem because the TI calculator uses a score statistic, and it should be easy for me to show you how this problem could be done using a calculator. So we know the sample size here is 44. We know that P naught, the claimed proportion, is 0.434, and P hat is the sample proportion, which is the number of students who use campus cinema, so x over n, where x is the number of students who use campus cinema divided by the total number of students we sampled. I believe P naught here was 21, not 22. It's 21. So P hat is 21 over 44, which turns out to be 0.4773. So the test statistic is obtained by plugging in those values that we have above. So it's 0.4773 minus 0.434 divided by the square root of P naught, which is 0.4773, times 1 minus P naught, which is 0.5227, divided by n, which is 44. If you plug this in the calculator, you'd find the answer to be 0.5791. So that is the test statistic. Now that we've found the test statistic, the next step is to find a conclusion. You should recognize that in step 4, we determine the distribution of the test statistic, which in this case is a standard normal. which means it has mean 0, standard deviation 1. Last step is to find a conclusion. In finding the conclusion, you could use one of two methods. You could either use the critical value method or the p-value method. At first, to the critical value method, where, since we know the test statistic has a normal distribution, I'd go ahead and draw the normal distribution. Then, I look at the test, and since the test is less than or equal to against greater than, you look at the alternative. The alternative is pointing to the right. So this is a right-tailed test, which tells me that the rejection region is on the right side. Since the rejection region is on the right side, so we could go ahead and sketch out the rejection region. The area of the rejection region is 0.1. And we're looking for the critical value, which is right over there, which is obtained from a normal distribution, so that the area below is 1 minus alpha. Because the area above is alpha, 1 minus alpha is 0.9 if the area above, which is alpha, is 0.1. We could find that critical value by using the function inverse norm 0.9. And if you do inverse norm 0.9 on your calculator, you will get the critical value. So I'm going to do inverse norm 0.9, close paren, enter, and the critical value is 1.282. So the critical value is at 1.282, and the test statistic from the previous part, step 3, is 0.5791, which is right over there. So 0.5791 would be here, close to 0. So that is the test statistic, 0.5791. The test statistic did not cross over the critical value into the rejection region. Therefore, with 90% confidence, we failed to reject the norm. So if you look back at our original hypothesis, the claim was in the alternative, and since we failed to reject the norm, the claim is false. So in this problem, the claim that is made is untrue. It's likely to be false, therefore we conclude that the claim is false. And the last, or the alternative way to find a conclusion, is using the p-value method. And if we happen to use the p-value method, we have to find the p-value. So the p-value for this test is the area above the test statistic, because this is a right-tailed test. For a right-tailed test, the p-value is the area above the test statistic. So going to go ahead and sketch a normal distribution, and the test statistic is 0.5791 from step 3. I'd like to find this area above. If I find the area above, I'll find the p-value. So in this problem, the p-value is normal CDF. Now, why am I using normal CDF? It is normal CDF because I'm trying to find the probability. I'm not trying to find a quantile. If you're trying to find a quantile, you'd use inverse norm. So you start at 0.5791, you end at infinity, which is E99, and that should give us the p-value. So I'll show you how to find that. Second verse again, go to option 2, 0.5791, comma, second comma, which will bring up E99, close paren, enter. And that probability is 0.2812 or 13. So, is p-value less than or equal to alpha? If you say yes, you reject null. If you say no, you fail to reject null. So, what should we say? By observing the p-value, it can be seen that the p-value is 0.2812. Is 0.2812 less than or equal to 0.1? The answer is no. So we fail to reject null. One of the interpretations of the p-value is that we have an evidence. So the evidence toward, or the probabilistic evidence toward the alternative is 1 minus p-value, and the evidence toward the null is the p-value itself. So the p-value here is 0.2812. Evidence toward the alternative is 1 minus 0.2812, which is 0.7188. So you look at it and say, well, this means there's about a 71.88% support toward the alternative and 28.12% support toward the null. It seems like that the alternative is more likely to be true, but that is not the case here. So at the beginning of the problem, we assign a permissible error in rejecting the null, which is nothing but the p-value. So p-value is the permissible error in rejecting null. And I would like this error to be 10% or less. That's what I did in step 2 by setting this alpha. But I have a 28.12% error. So even though I find 71.88% probabilistic evidence toward the alternative, the error that I'll have in rejecting that alternative is 28.12%. Therefore, I failed to reject the null. Next, I'll show you how this problem could be done using a calculator. So, if we go back to our question, we have P naught, we have the claimed, which is the claimed value, we have x, n, and all. So press press start, go over to tests, and select number 5, which stands for 1 proportion z test, and we have P naught, which is 0.434, which is the claimed value, which is greater than 43.4%. The number of students who use campus cinema out of the 44 is 21, so x is 21, n is 44, and you have to select the type of test. I have selected the third one because clearly by looking at the alternative, this is a right-tail test. Now, when I press calculate, I'm going to get the conclusion of the test. You can see that the test statistic is 0.5791, which is exactly what I have in my problem here. And the p-value is 0.2812, which is right over there. So the calculator can do almost everything for you if it is a score statistic. In addition, if you want to sketch the p-value, you can go to 5, and instead of calculating, you just draw. If you press draw, you can see that the calculator sketches out a p-value very similar to what I had sketched out here. So that is how you perform a right-tail test using the score statistic, using the manual approach, as well as a TI-84 calculator. I hope you liked this video. Thank you for watching.